Hello students, today in this video we are going to finish class 10 maths chapter 1 real numbers. In this video we will cover all the basic concepts, the most important NCERT solutions, guaranteed board exam questions right from the zero levels. Welcome to Maths Made Easy, where we make toughest maths concept absolutely simple. So without any delay, grab your pen and notebook and let's cross this chapter together. Let's start. Exercise 1.1, Fundamental Theorem of Arithmetics. This exercise is based on prime number and HCF and LCM. Fundamental Theorem of Arithmetic says every composite number can be written or expressed as a product of prime numbers. According to this theorem, we can say every composite number is a multiple of any prime number, and any prime number is factor of any composite number. Next is relationship. For two positive integers a and b, HCF of a and b times LCM of a and b is equal to product of a and b. What is HCF? HCF is the highest common factor and LCM is the least common multiple. Next exercise 1.1 is revisiting irrational number. This exercise is based on proof of contradiction. Now, what is the contradiction? We will learn this in further questions. The question says, express each number as a product of its prime number. Now, this is the question of prime factorization. So, before solving this question, let's remember what is the prime numbers. Which numbers are prime numbers? Now, we say prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and so on. The number does not have more than two factors. It's called prime number. So prime number 2, 3, 5, 7, 11, 13, 17, and so on. Let's take first option 140. Check the divisibility by 2. If I divide 140 by 2, I get 70. Now 70 is also divisible by 2. Now divide by 2, I get 35. Now 35 is not divisible by 2 and also not divisible by 3, but divisible by 5. So if I divide by 5, I get 7. And now 7 is also a prime number. So I divide by 7 to get 1. Prime factors of 140 is 2 times 2 times 5 times 7. And I also write this. 140 is equals to 2 square times 5 times 7. Now please check this number. Is this divisible by 2? No. This don't have any multiple of 2 in this unit digit. So this will not divisible by 2. Also not divisible by 3. Also not divisible by 5. 7, 11, 13, 17. Oh, is this divisible by 17 or not? Let's check. How to check 17, 19, 23 and so on divisibility? If you want me to make the video of checking the divisibility of any prime number, so comment me. Now find the factors of 7429. I have checked this number is not divisible by 13, but it is divisible by 17. So let's divide it by 17. So if I divide it by 17, I got 17 4s are 68. 17 3s are 51 and 17 7s are 118. Now this number is divisible by 19. If I divide it by 19, I got 19 2s are 38 and 19 3s are 57. Now this is 23 is also a prime number, so I will divide it by 23 to get 1. So prime factors of 7429 is 17 into 19 into 23. 5005. If I check divisibility by 2, this number is not divisible by 2 and also is not divisible by 3. So I will check 5. It has unit digit is 5. So it is divisible by 5. 5 ones are 5 and 2 zeros. 5 ones are 5. This number is not divisible by 5. So I will check 7. 7 is divisible by 1001. So if I divide this number by 7, I get 7 ones are 7, got 30. 7 4s are 28, got 2. 7 3s are 21. Now this number is divisible by 11. 11 ones are 11. 11 3s are 13. 33. If this number is prime number, so I will divide it by 13 to get 1. So 5005 can be written as a prime numbers 5 times 7 times 11 times 13. This is the prime factorization of. I hope you understood what is the prime factorization. Now we will use this method to find HCF and LCM of any two number or three numbers. In this chapter, this is the most important concept and the basic concept of arithmetic. This question is saying check whether 6 raised to n can end with the digit 0 for any value of n. So we remember every number ends with 0 does have 2 times 5 product of 2 and 5 in its prime factors. But 6 is have 2 but don't have 5 in its prime factors. So 6 raised to n cannot end with 0 for any value of natural number n. Now third question is explain whether following numbers are prime or composite number. We have to check these numbers are prime or co-prime. Composite. So we know that a prime number is that number who does not have more than 2 factors, and composite number that have more than 2 factors. Oh. The third question is explain whether following numbers are prime or composite. Before solving this question, we should remember that what is prime number and composite number. Let's recall. Prime number is that number who does not have more than 2 factors. 1 and itself, and composite number is that number who have more than 2 factors. So we should check which number have only 2 factors, 1 and itself, and which number does have more than 2 factors. After that, we will categorize which number is composite and which number is prime. Let's check first. 7 into 11 times 13 plus 13. Now, let's take common 13 from both terms. 7 into 11 into 1 plus 1. Now, this number can be written as the product of 13 and whatever this number. So, we can say that this number have more than 2 factors. So, this number will be composite. This number have more than 2 factors. So, this is a composite number. That's it. If you want to check whether the number is composite or prime, you should check the prime factors. HCF and LCM of 2 consecutive positive integers is. So this is a tricky question. Now we should remember what is the co-prime numbers. Now should write that all consecutive positive numbers are co-prime numbers. So we can say that HCF and LCM of any 2 consecutive numbers is if A and B are 2 consecutive numbers, then HCF of A and B is 1 because they are co-prime, and LCM of A and B is A cross B. You can also solve this question by taking any 2 consecutive numbers as an example and find their HCF and LCM. Now let's dive into this question. If P and Q are 2 distinct prime numbers, then their HCF is P and Q are distinct prime numbers. This is very simple question. as we know that prime numbers does not have more than two factors, one and itself, no other factor. So P and Q are prime numbers. Then they also don't have common factor because they only have common factor is 1. Okay. Now the solution of this question is all prime numbers does not have more than two factors. One and itself. So if P and Q are two distinct prime numbers, then they will have only one as a common factor. HCF of P and Q is equals to 1. Now this question saying ratio of LCM and HCF of the least composite and least prime number. First, we know that least composite number. What is least composite number? 4. And least prime is 2. Ratio of LCM and HCF. Now, LCM of 4 and 2 is 4 and HCF of 4 and 2 is 2. So, ratio of LCM and HCF. So, LCM of 4 and 2 ratio HCF of 4 and 2 is equals to 4 ratio 2 is equals to 2 ratio 1. Now read this question. Two positive integers a and b can be written as a equals to x cube y square and b equals to x y cube, where x and y are prime numbers. Then find LCM of AB. To find LCM of AB, we should take higher power of that prime numbers. Here x power is 3, here x power is 1, higher power is 3. So we will take LCM of AB equals to higher power of x is x cube and higher power of y is y cube. If the question asks us HCF of AB, now we should take a least power of prime numbers. Least power of prime number is there x power 3, x power 1, least power is 1, so x. And here x power 3 and x raised to 2. Now least power is 2. Now let's read this question. If x is equals to ab cube, y is equals to a cube b, where a and b are prime numbers, then find the HCF and LCM. This question is same as the 7th question, so do it yourself. Now next question is, if the LCM of two numbers is 3600, then which of the following number cannot be HCF? Before solving this question, we should know that LCM of any two numbers is always a multiple of its factor. And we also can say that HCF of any two number is always a factor of LCM. 600 is divisor of 3600, 3600, and 500 is not a divisor of 3600. So the option B, 500, is our correct answer, because 500 cannot be the HCF if LCM of any two number is 3600. Now let's look at this question. Find HCF and LCM. Solve the first option. 12, 15, and 21. First, we have to take a prime factorization of all numbers. First 12, second 15, and third 21. This is a rough work. 12 is divisible by 2. Now 6 is also divisible by 2. And 3. Now 12 has prime factor is 2 square times 3. 15 is 3 times 5. 21 has 3 times 7. Now we can say that HCF of 12, 15, and 21, we can find the common factor of these numbers is 3, and LCM of these numbers is common factor of these numbers, because common factor is always a factor of LCM. And take 2 square, take 5, and take 7. Now we will solve it. 7, 5 is 35, and 35, 4 is 140, and 140, 3 is 420. Now second one is 17, 23, 29. Now we know that all three numbers are prime numbers. So HCF of these numbers is 1, and LCM of these numbers is 7429, as we solved this number in our first question. Third is 8, 9, and 25. So first prime factorize all of these numbers. 8 is divisible by 2, we get 4. Also divisible by 2, we get 2 and 2, 1, 3, 3, 3, 1, 5, we get 5, 5 and 1. So if we write 8, 2 cube and 9, 3 square and 5, 25, 5 square. So we can say these numbers does not have common factor. So the HCF of this number is 1 and LCM of these numbers is 8 into 9 into 25. So please solve. Twenty-five 8s are 200 multiplied by 9 is 1800. Fourth option, do it yourself. Now read this question. Find the HCF and LCM of following pair of integers and verify that. Now we have to verify our answer. So please remember this relationship. Now we have to solve. The first option is 26 and 91. Factorize separate 26, 13 and 13 is real number. 91 is not divisible by 2 and also not by 3 and also not divisible by 5 but also divisible by 7. So we get now we can write 26 as a product of 2 into 13 and 91 as a product of 7 into 30. So from this factorization we can say HCF is 13 and LCM of 26 and 91 is 13 into 2 into 7. So verify that. If we verify if these are right, it will also satisfy this formula. So we should write that value of HCF and LCM of 26 and 91 are satisfying the relationship between product of HCF and LCM and product of numbers. So we can say that this value of HCF and LCM is right. Now let's solve this question. Factorize both of them. It will divisible by 3. 3 8s are 24 and 3 5s are 15. Now 8 plus 5 is 13, is not divisible by 3. So we will go for 5. Now 5 1s are 5 and 5 3s 5 7s are 35. 17 is prime number, so we will divide 17. 92 divisible by 2. So 4 2s are 8 and 6 2s are 12. 2 2s are 4 and 3 2s are 6. 23 is prime number, so we will divide 23 to get 1. Now 5 10 is equals to 2 times 5 or 3 times 5 times 17, and 92 is 2 times 2 times 23. So HCF of 5 10 and 92 is equals to, there is only one common factor, so the HCF of 510 and 92 is 2, and LCM of 510 and 92 is also getting 2 and another 2 and 3 and 5 and 17 and 23. So verify that HCF of 510 and 92 times LCM of 510 and 92 is equals to 510 into 92. So HCF is 2 and LCM is 2 square and 3 times 5 times 17 times 23. We can write 510 as a prime factors. 2 into 3 to 5 into 17 into 92 as a 2 square into 23. So we can say 23, 23, 17, 17, 5, 5, 3, 3, 2, 2 and 2 square, 2 square. So whole number is equal, so 1 is equal to 1. Now we can say that value of HCF and LCM is satisfying the formula. Then the value is right.